In this video, we'll learn how to do logarithmic differentiation of implicit functions. So let's do that with an example. X to the power y equals to y to the power x. This is an implicit function in x and y, and we're asked to find dy by dx. How do we begin? How do we separate y and x? We can't. That's where logarithmic differentiation comes into play. We can do this by taking log on both the sides. That's usually the first step for these problems. So what do you get when you take log on both sides? Pause the video. Think about it. Okay. Treat these powers y and x as powers. And when you take log, you get log of x to the power y equals to log of y to the power x. So this y comes down and this x comes down. The property of log says log of x to the power a is equal to a times log of x. So this becomes y log of x plus x log of y. Now we don't have anything in the powers. The exponents are taken care of. What next? Can we do differentiation on the left hand side and differentiation on the right hand side? Yes, we can. And which rule we'll use? Well, we have y and log x. Both of these are functions and will be differentiated separately. So we'll use product rule here. Here as well, we have product rule. So we have two functions u and v, and applying dy by dx on both the sides, we'll have d by dx of y log x equals to d by dx of x log y. So this is the step where we involve differentiation. The log is required to bring the powers down. Now we can use product rule. So this becomes differentiation of y times log x as it is plus y as it is differentiation of log x. We're differentiating uv, that's uv dash plus vu dash. Okay, what's on the right hand side? We have d by dx of x. X is itself a function. So this becomes dx by dx times log y as it is plus x as it is times d by dx of log y. And now it's our time, because we have used the product rule. Now is our time to actually differentiate. So dy by dx remains as it is. This is what we need to figure out. Log x plus y times differentiation of log x, that's 1 upon x. So this becomes y by x. This is equal to differentiation of x with respect to x. This is going to be equal to 1. This is 1 times log y, which is log y, plus x times differentiation of y with respect to x. And we have to be careful here. This is differentiation of log y with respect to x. So here we'll use the chain rule. So differentiation of log y with respect to y is 1 by y. And then we'll multiply it with the differentiation of y with respect to x. That's dy by dx. So this is a key step. Okay. So we have differentiated. Now we have the relation between y, x, functions of y, functions of x, and dy by dx. So to clean all of this up, we'll move everything on one side and keep dy by dx on another. So let's separate for dy by dx. We have dy by dx times log x minus x by y. This term goes to this side. So dy by dx times log x minus x by y. That's on the left hand side. And what's on the right hand side? We have log y minus y by x. So log y minus y by x. Now to get dy by dx, we'll just divide both sides by log x minus x by y. So we get dy by dx equals to log y minus y by x divided by log x minus x by y. And to write things neatly, we'll take the LCM. We have 1 by x common in the numerator. We have x log y minus y, and denominator has 1 by y common, y log x minus x. This y comes on top. So this becomes y by x times x log y minus y divided by y log x minus x. And this is dy by dx when x and y are related like this. Let's solve one more problem. This time, let's also include trigonometry. Cos of x to the power of y equals to cos of y to the power of x. Find dy by dx. Pause the video. Try this on your own. Okay, let's do this together. Step 1 is always to get rid of the powers. So let's take log on both sides. Log of cos of x to the power of y equals to log of cos of y to the power x. Here y can come down and here x can come down. We have y log of cos of x equals to x log of cos of y. Now we can differentiate both sides. this is y times log of cos of x. This is a compound function, but these are two functions, y and the other one is log of cos of x. So we'll differentiate one keeping the other constant, and then we'll differentiate the other one keeping the first one constant. So we'll use product rule here. We'll use product rule here as well. We have x and the other function is log of cos of y. So let's do this step by step. For the left hand side, we have y as it is, differentiation of d by dx of log of cos of x plus differentiation of y, which is dy by dx times log of cos of x as it is. So that's the left hand side. Right hand side is x as it is with respect to x, differentiation of log of cos of y plus differentiation of x with respect to x, we can just write it as 1 times this function as it is, log of cos of y. All right, now we can actually differentiate. This is y times differentiation of log of cos of x with respect to x. Now here we can use the chain rule. First we'll differentiate log of cos of x with respect to cos of x. So log of something, that's 1 upon that. So y times 1 upon cos of x times, now differentiation of cos x with respect to x, that's minus sin x. So this term becomes y by cos x times minus sin x. What about the next one? We have dy by dx times log of cos of x, same thing. What about the next one? We have x times differentiation with respect to x of log of cos of y. So here we have chain rule. First we differentiate the log, that's 1 upon cos of y. Then we differentiate cos, that's minus sin y. And then we don't have to forget this one. We have to differentiate y with respect to x as well. So that's dy by dx. This is the function in y, but we're differentiating with respect to x. So that's dy by dx plus log of cos of y as it is. Now let's simplify. We have dy by dx log of cos of x plus this term which also has dy by dx. Let's move this to this side. We have plus x sin y by cos y dy by dx. That's equal to this term log of cos of y, this term minus y sin x by cos x. So this moves to this side. This becomes y sin x by cos x. All right. So we have dy by dx common. This becomes log of cos of x plus x sin y by cos y. We can put this in the denominator, and the numerator is y sin x by cos x plus log cos of y. Sin x by cos x is tan x, sin y by cos y is tan y. So this becomes dy by dx equals to y tan x plus log cos y divided by log cos x plus x tan y. So that's our dy by dx for this implicit function.